Hello, this one's about enthalpy types, all sorts of enthalpy. So you need to be able to identify what you're looking at to be able to describe what enthalpy it is, enthalpy change of what, and the definitions are important. So make sure you understand it. You're going to have to think logically about what you're looking at, and I'll try and explain how you do that. So here's a reaction. 2 carbon atoms plus 3 hydrogen molecules plus half an oxygen molecule make ethanol. So we're making something. On the left-hand side of the equation, we've got only elements. No compounds over there. We've got a compound on the right. So we're making anything. It's formation. So we call this enthalpy of formation. And we get delta HF. Now, if you look, we've got standard states here. These are the states that these items would be at standard conditions, standard temperature and pressure. Therefore, it is standard enthalpy of formation, or delta H bus stop sign F. Have a look at this one. Ethanol reacting with oxygen to form carbon dioxide and water. Now that's the key. On the right, if we've got carbon dioxide and water, and on the left we've got something with oxygen, it is a combustion reaction. So we would call that standard enthalpy of combustion. Now we need to talk about the full definition here. This is the enthalpy change when 1 mole of a compound, in this case ethanol, is fully burnt, combustion, complete combustion to form carbon dioxide and water. Okay, so the enthalpy change when 1 mole of a compound is undergoes complete combustion. Okay, now similarly, when we were looking at the previous example, we were looking at the enthalpy of formation. Again, it's the enthalpy of formation of 1 mole of whatever you're talking about. That's important under standard conditions. Next one, what's this? Right, this is dehydrogenation of ethanol. It's not combustion. We're not making anything from elements, so this is just termed standard enthalpy of reaction. Again, you need to get the understanding of the definitions. We're talking about under standard conditions. However, if you look at this example, this is also standard enthalpy of reaction. So we don't have to have just 1 mole of something here. It is the we look at the equation and we just talk about the standard enthalpy of reaction for that equation. So if it requires 2 moles here, which it requires 2 moles, so you actually end up with a diatomic hydrogen at the end, that's fine. Okay. Also going to talk about the 2 other forms of enthalpy. Bond enthalpy here. So definition: the energy needed to break 1 mole of bonds. Now in this case we're breaking the OH bond. So the energy needed to break 1 mole of OH bonds in the gaseous state. Now we do that because we're actually talking about the OH bond specifically, not in a particular compound, not in ethanol, not in water, not in calcium hydroxide. We're talking generally. Therefore, to make it a fair comparison, we talk about breaking the bonds when whatever compound it's in is in a gaseous state, and it's an average value, so there will be variation of breaking the OH bond in methanol compared to water, compared to calcium hydroxide. So we're talking about an average value here, but it's still energy needed to break 1 mole of bonds, but it's in the gaseous state. Remember that if you're talking about breaking bonds, it's going to be a positive value. That's an endothermic reaction, and if we're talking about making bonds, that releases energy, so that's an exothermic reaction. And finally, we'll mention ionization energy. You call it ion. I'm going to put it in there. Ionization enthalpy. We do tend to say ionization energy, but it's an enthalpy change. So here we go. The definition is the energy needed to remove one electron from each atom in 1 mole of gaseous atoms. Okay, so we use the gaseous state for that again. So ionization enthalpy. And of course, you remember you can have first ionization, second ionization, and so on. Have a look at these little reminders.
Never said it would be this hard. Oh, take me back to the start.